Hello all. As you can see from this video, that these are actually the notes from Friday the 13th. These are just making sure everybody's on the same page to begin out our couple weeks of online lessons. Putting stuff up for those of you who weren't able to make it to school on Friday. So we'll start here for today's lesson. This is Wednesday, March 18th lesson, and we're going to talk about convection currents and the wind. If you have already done these notes, you may be able to go ahead and skip to the questions for the notes packet on this on this quiz, on this homework quiz. So first thing, the question for the day, the do now, was how does a convection current form? And we narrowed it down to a couple of steps. So the first thing that happens is that matter, usually a fluid, will heat up. It's near a heat source and that matter heats up. Now, whenever anything heats up, the molecules begin to move faster and they shove against each other, which means they expand. And because of how density works and gravity works, that expanded matter begins to rise and go up. Now that's if the heat source is at the bottom of the space. It's going to act a little different if the heat source is at the top, but we'll talk about that later. So this, after it heats up and it rises and it moves away from the heat source, that matter is going to begin to cool. And as it cools, the molecules start to slow down. They don't press each other against each other as much, and they start to condense, become more dense. And when they do that, they sink. So those are the steps that we came up with on Friday for our convection currents. So today, what we're going to focus on is more information about how or influences climate. Now, the first thing we learned about was the sun's rays and those seasons and the indirect sunlight. But today we're going to talk about convection currents and how air currents actually can create a bigger, or can be a big influence as well. They're probably our second most influential climatic effect. So first things, let's go ahead and fill in our notes. As you saw a convection current back there, what's going to happen is that our atmosphere has very large, like we're talking size of nations, convection currents. So first thing that happens is the solar energy warms the ground, which you saw back here on this. There's the ground. So the sun's going to come down, and the earth itself is warm just because it has so much mass there. It's a little more. The sun comes down and it actually heats the ground, heats the air right above it, right above the ground. So it starts to get warmer, heats up, that air will rise. Now I want to remind you that warm air can hold more water vapor than cold air. So what's going to happen is that warm air, as it warms up, it's actually going to start to take water out of or it's going to have water out of the ground. So it picks up the water out of the ocean and the land, wherever it can get that moisture from, because it's heating up, it wants that moisture, it's going to take it from whether it's our wood furniture, our skin, or the soil under our feet. Okay. Now, as the air rises, it's going to get away from that heat source and it's begin to cool. Now, as it cools, again, it's how air holds more water than cold air. So as it cools, it's not going to be able. It's going to start to lose water. In other words, it's going to create precipitation. And you can see that on this diagram right here that's in your notes. So these are our big convection currents right here. Okay, it says air is warmed at 0 degrees, moves away from the equator before cooling and sinking down at 30 degrees. So this is actually looking at Earth from the side. Okay, so here's the equator here in the center that you can see. And this is where we're going to get the most sunlight occurring, or the largest concentration of sunlight occurring. So the air here is going to be warmer than the air above it. So the air here starts to heat up, and when it heats up, it rises, as you can see with the red arrows. But then, as it moves away from the earth, it's going to start to cool down. So this cool air here can't hold that water, and it drops it. And if you notice, it drops the water right over the equator. Now this is really cool because these Hadley cells, these large convection currents as we call them, Hadley cells, actually occur in a couple different regions. So here we have the 0 to 30 at the equator. We can also see it from 30 to 60 on both sides, and then from 60 to 90 at the poles. Okay, now the other thing you notice here, you see water, but you also notice these cacti. So let's go back here for a second. As this air cools, it's going to sink, and what's going to happen when it gets back down here? It's actually going to start heating up again. So on Friday, I asked some students to take a trip with me to Africa. But in Africa, I asked the students to tell me ask if they could show me where the equator is. We had a couple different answers. First of all, we had that the equator was right here at this line. They said it made sense because the desert was really, really hot, and that this line was probably the result of the equator. Some said actually the equator is a little higher right here in the center of that desert. But a couple of students actually were able to tell me that the equator occurs right here. And they're absolutely right. If you take a look at your biomes map that we did at the end of sections or during section 6 before we started this unit, or not the atmosphere, section 5, the biomes, you can see that the equator goes right here. How do we know that? Well, if you look back to our notes, you'll see that the rain comes right at the equator. Well, rain means green, means water, plenty of water for things to grow. So where is our forest most dense? What do we have? If you look at your biomes map, you'll see that most of our tropical rainforests, or all the tropical rainforests, occur right at the equator. So you can see here in the Philippines, another portion, and continuing around, going back to South America, our biggest rainforests, we're going to have, there we go, whoop, the Amazon also lies along the equator. Now back to Africa, and you'll see that line of the equator. But if the rainforest is here, why do we have desert there? And it's the same thing as you'll see in this diagram right here. As the air comes back down and heats up, it's going to be able to hold more moisture. So it has to get moisture from wherever it can. And in the case of Africa, there's no ocean here, so it's going to get the moisture from the land itself. So that's why the Sahara Desert is where it's located where it is. It's because there's no water there for it to get its moisture from. Now, if you look at below it, the same thing should happen. This is about 30 degrees above the equator. This is about 30 degrees below the equator. Now, the same thing. It's going to be drier down here. Why is it not completely dry? Well, students on Friday guessed correctly. That's because there's a lot more ocean here. So this ocean sort of acts as a buffer and allows the air to keep moisture for itself, and also brings some moisture onto the land. But that 30 degrees also explains why Australia, sorry, we're sort of tipping here, let me straighten this back up. Australia is mostly desert. Why? Because it cuts right there at that 30-degree line where the air is coming back down, those global currents are coming back down, and the air is trying to get more moisture. So it lost moisture here in the tropical rainforest, and it's gaining moisture in the big land masses about 30 degrees. There are a couple of other things that happen with this. Because we have these big convection currents, we actually have some big, what we call prevailing winds. Now, air is going to move like any other process of science where you have differentiation of pressure, like osmosis or diffusion. The air is going to move from an area of high pressure to areas of low pressure to create wind. Okay, so when we have wind, it's going literally the movement of high pressure air to low pressure air. Okay. That's not the only thing that's going to happen with our wind. Because of the Earth rotation, the atmosphere sits above the Earth, so that the Earth is actually rotating below the atmosphere, and it looks like the wind is moving right in the northern hemisphere and left in the southern hemisphere. This is known as the Coriolis effect. So the Coriolis effect is when we see that change in motion of the air from the right or left. You can see it on this website here. Okay. You can see the air movements, there they go, going right here, and it's coming up and going to the left from here, so going to the right down here and left up there. It also explains why hurricanes or other major wind currents, this isn't a hurricane, but do you see how it's rotating in one direction down here, and it'll rotate in the opposite direction on the other side? Okay, so that's what happens with our air currents. Now those winds have names to them, and you can see the first one is known as the trade winds. That is from 0 to 30 degrees north and 0 to 30 degrees south of the equator. Let me go back to that image right here, and the reason they're called the trade winds is actually because those are the winds that were used by traders during the 1400s, 1500s. We were learning to circumnavigate the globe, and we were learning all of this. Those are the winds that the traders used to get to the West Indies, which is now Bahamas and the islands down here in the Gulf of Mexico. So, but those winds were what carried out those trade routes, so we call them the trade winds. Now, the second row, actually you can see it right here, right above the United States, are called the westerlies, and if you pay attention to the weather, you might notice that most of our weather comes out of the west, and that's because that's where most of our wind is coming from. As we rotate, the wind those convection currents coming back down create westerly wind. Now on the North Pole, opposite's going to happen. As the convection currents come back down, we'll have the polar easterlies. So that's it for right now. We're going to go ahead and stop here, and you guys will start to answer answer some questions on these notes, and I hope you guys have a great day. Thank you. Bye.